Okay, what we have here is my project. It's a personal weather station, or if you want to be fancy, you can say meteorological station, but that's a mouthful and it's really hard to spell. So we'll stay with personal weather station, or PWS. We'll take you through some of the different elements here and then get into a little bit more detail afterwards. Right now this is a temporary installation. It's living on a microphone stand for portability and demonstration purposes at the college. Eventually it will be permanently mounted on the garage. You can see left of screen. At the top there's an anemometer, which consists of wind speed and direction. Those are two different sensors. Moving down, this is an enclosure inside which is a temperature sensor, barometric pressure sensor, and a relative humidity sensor. This part here is, of course, a solar panel, 9-watt solar panel. It is charging inside this box a 12 amp hour LiPo battery pack, which has conveniently two USB ports on it, and those USB ports are powering a couple of different pieces of hardware on this proto board. On the top or the left is a Wi-Fi module, and it's a little hard to see with all the wires, but in the center of the board is a Arduino Pro Mini, and that's really the heart of the system. And then you look at this enclosure here. This is a really nice weatherproof, waterproof enclosure, which brings in the signals through the back. Let's see, the anemometer. The wind direction is really a potentiometer. It's powered by 5 volts. You can see it spinning, and depending upon the direction that it's pointed in, it will put out a different voltage. That voltage is fed down to the one of the analog pins on the Arduino. The wind speed, or the cups below, that's a digital signal, so it's pulled up through a pull-up resistor to 5 volts. And once per revolution, a reed switch makes a contact and pulls the signal low. That signal is attached to a digital pin on the Arduino, and we're counting the number of times it goes low and averaging that over a period of time, and then doing a little bit of math to determine wind speed based on a specification put out by the manufacturer of the anemometer. Let's see if I can pop this open. We're getting barometric pressure and humidity from the printed circuit board on the right, and temperature from the sensor on the left. Those are fed down. On the right, the sensor is fed down actually to the I2C bus on the Arduino, and then the sensor on the left is fed again to another digital pin on the Arduino. What else can I say here? The battery pack has a really nifty feature. It's always on. So what I'm doing is, for power savings, I'm putting both of the modules on the proto board to sleep for about 80% of the time. They're in a ultra low power consumption state, and then they wake up periodically to take a data set and send that up to Weather Underground. I calculated the amount of power that I thought I was going to use, and then basically doubled it. So I don't anticipate having issues with battery life, except to say that the specification on the LiPo battery pack temperature-wise is down to 0 degrees Fahrenheit. Manufacturer suggests that they have several customers using the LiPo battery well below that, but they won't guarantee it. So we usually see negative 25 Fahrenheit here in any given winter. So I guess we'll just have to wait and see how that works out. That's basically it. Thanks.